Tornadoes. They can appear at any time and devastate entire regions. Their rotational speed up to 500 kilometers per hour. With a diameter of up to 1,000 meters.
The biggest threat that comes with tornadoes is debris that might be thrown around in the air.
Tornadoes.
The roof of the building just blew off.
Destroy cars, caravans, and even houses.
Tornadoes are complex climatic events, and today we have limited knowledge on exactly where they occur and how strong they will be. But at least we have technology that helps us make prognosis, and that equals to saving lives.
Can we use modern technology today in the 21st century to effectively counter this threat? Chapter 1, Detection. How can we detect a tornado early? Chapter 2, Pursuit. How can we predict its direction? And finally, Chapter 3, Impact. What are our chances when a tornado heads straight for our towns and villages? We'll find out on Facing Forces of Nature. Tornadoes form when layers of air with different temperatures meet. The reason? Cold air is heavier and thus moves downwards towards the Earth. Warm air, on the other hand, rises. The result? Rotating air forms thunderclouds. Crucial to all this is the wind moving overhead at various speeds and directions, whirling up the storm clouds. Weaker tornadoes usually form from smaller cloud formations.
So these rotating columns of air tend to be in the troposphere, so that's the layer of the Earth's atmosphere that's closest to the ground. And tornadoes tend to be within something like 100 meters of the ground. They tend not to be that high relative to the Earth's atmosphere, but a 100-meter column of tornado is still quite scary, I think.
Sometimes many thunderclouds join force at the same time to create one huge twister. They are known as supercells. First, this requires warm, moist air on the ground, flowing upwards at a rapid pace. At over 14 kilometers per hour. It cools down quickly in the process. This becomes the engine of the storm. Winds at the very top create so-called vertical shear, and in extreme cases, twirl the air flowing upwards. These supercells produce extreme storms, producing up to 500,000 tons of hailstorms the size of tennis balls. That's the equivalent of about 10 billion tennis balls, enough to fill about 3,200 dump trucks. All this happens within a few hours. This could quickly turn 3 lanes of highway into a 65-kilometer-long traffic jam.
So tornadoes are formed when hot, humid air collides with cold, dry air. This causes a updraft, air moving vertically, and then that causes the circular motion as well. The tornadoes form from the supercells, but we don't actually know when a tornado is born out of a supercell.
When such an air rotation occurs, a vortex eventually forms. When it touches ground, a tornado is born. Weaker tornadoes cause only light damage. With a rotational speed of up to 180 kilometers per hour, they are capable of ripping branches from trees and sweeping cars off the road. Tornadoes classified as strong reach a rotational speed of up to 343 kilometers per hour. They can lift entire trains off their tracks and hurl them through the air. In extreme cases, devastating tornadoes with wind speeds beyond 400 kilometers per hour turn even very heavy objects into projectiles and can rip entire houses to pieces.
These are really the strongest winds that you can find on our planet. And they exist only in tornadoes, not in other types of storms. And at these wind speeds, a straw has the power to take someone's life.
Their emergence is hardly predictable. So with what's available today, do we have the means to defy the forces of nature? It all begins with a seemingly normal thunderstorm.
So meteorologists who study the weather are able to look at weather patterns, and in particular how masses of air are moving relative to one another. That's really what causes tornadoes to form, is different masses of air, particularly cold masses of air meeting warm masses of air, that gives rise to tornadoes. By looking at these patterns, it's not obvious whether a tornado is going to form, but they can give some sort of indication of what's going to take place.
At this moment, the battle begins. Man against the force of nature. Our first weapon in this battle is real-time data from the atmosphere. In most cases, a tornado forms within a few short minutes. So-called numerical weather prediction makes it possible to predict conspicuous wind currents in the atmosphere.
Any data is relevant. On the ground, we measure with radars and temperature sensors and humidity sensors. But more importantly, also, we have to look at the vertical distribution of these properties, how humidity is higher up, what the temperatures. And for that, we attach these instruments to balloons and also aircraft. And so you form a vertical profile. The more information you get vertically and horizontally, the better you're placed in predicting when a tornado will form.
Around 5,000 commercial aircraft alone provide a wealth of data collected at different altitudes around the globe. Their findings are of particular importance. Because the jet stream flows where airplanes usually fly, at an altitude of 10 to 12 kilometers. It separates cold polar air from subtropical warm air. Although the jet stream moves at that altitude, it affects pressure conditions on the ground, playing an important role in weather forecasting. In addition to the data from aircraft, other measurement technologies are also used, like radar. Radar can detect rotational movements in the air as early as possible. They identify supercells and, if necessary, can track them. A worldwide network of weather stations uses radar technology to measure air temperature and pressure, as well as humidity, precipitation, and wind speed, 365 days a year. But there are gaps. Depending on the region, the density of the network varies, and with it, its precision.
In practice, lots of that information comes from weather stations, which are these isolated locations where you get this information, basically. And of course, because that's a fixed location, you only have this information about particular points in the region. And so it would be really great if you could know those things everywhere, but of course you can't. So weather stations really aren't enough to be able to predict whether a tornado is going to take place.
The solution is so-called radiosondes. Meteorologists send them with weather balloons several times a day to the borders of our atmosphere. They enable further punctual measurements and fill the data gaps as much as possible. On their way up, the probes gather information about how air pressure, humidity, and temperature change with increasing altitude, until the balloon bursts at an altitude of 20 to 30 kilometers due to decreasing air pressure. The radiosonde then falls back to Earth, slowed by a parachute. Meteorologists then evaluate these readings as quickly as possible.
The problem is you cannot launch an infinite variety of balloons or infinite quantity. We want as much data as possible, and the more we have, the more accurate the predictions will be. But there's a practical problem that you cannot launch more than a certain number of radiosondes and balloons.
The next critical component in the fight against tornadoes is weather satellites. They supplement the timely measurements of the radiosondes with global measurement data.
Weather satellites collect a lot of data. For example, temperatures on the ground, cloud coverage, precipitation, wind speeds, and together they are producing a three-dimensional picture of the weather around the globe.
Weather satellites reside in geostationary orbit. That means they orbit the Earth parallel to the equator at an altitude of just under 36,000 kilometers. Their rotational speed is identical to that of the Earth, so they are always hovering over the same region. From there, they scan our atmosphere in the visible and the infrared range.
What a satellite does not give you is the accurate local resolution and the vertical distribution of temperatures, of winds, and of humidity. And those are the informations that you need in order to be able to predict the formation of tornadoes.
Only by connecting all measured data are we able to estimate when a tornado could form. The average lead time is just 10 to 15 minutes.
So the information that's collected from weather stations and from monitoring stations it goes into the models that scientists use to predict whether tornadoes are going to take place. So these models basically describe how the air is moving and what temperature it has and what the pressure is, and it tries to basically create a picture of what's going on the ground. And the better the data that is, the better the quality, the more we have, then generally the better those predictions will be, and the more likely it is that accurate predictions of whether tornadoes are going to take place will happen.
Clouds, even supercells, present another problem, as they are constantly moving. For a long time, it's been difficult not only to determine when a tornado could form, but also where. Fortunately, the movement of clouds is quite predictable, as they usually follow a funnel-shaped track. Based on this, meteorologists can prepare a risk assessment for a larger area. This is nothing more than a forecast, but it acts as an important early warning to the population. One of the countries most affected by tornadoes is the United States. They also have the most extensive warning system.
Radar systems have revolutionized our ability to warn people ahead of time. What used to be a warning time of 1 to 2 minutes now has become 10 to 15 minutes. A radar system will measure wind speeds at a few kilometers distance. You can then predict that, or you can try and predict that the tornado will come your way. But ultimately, tornadoes are wild beasts, and you never know where they will go. So you cannot accurately warn people. You can only try from the radar signal.
In the U.S., there is a system known as Tornado Watch. It's an early warning system initiated from the relevant weather service authorities, which dispatches hours before a potential tornado can form. It's broadcast over all media, television, radio, internet, and even digital road signs. From this moment on, those in the affected areas have to keep an eye on the developing weather situation to stay up to date.
So people living in tornado-prone areas are taught to act quickly. They should watch out for the news and then review their supplies and their evacuation plans, because time is really important and can save lives.
The west side of Bergen, we have a major tornado coming.
As late as the 1980s, tornadoes continued to surprise unsuspecting victims. And early warning was nearly impossible. Countries with minimal technology are usually hit the hardest.
Sadly, many communities still don't have sufficient protection from the impacts of severe storms, and they would still benefit from early warning systems.
That was the case with the world's deadliest tornado ever documented in history. It occurred in 1989 in Bangladesh, destroying the cities of Maniganj Sadar and Saturia. The consequences: some 1,300 people dead, more than 12,000 injured, and 80,000 people left homeless.
So this was really one of the biggest observed storms with the deadliest consequences. It destroyed a path of about 80 kilometers and devastated an area of 150 square kilometers. And this could happen at any point, not just in Bangladesh.
Whether in Asia, the US, or Europe, tornadoes continue to threaten to destroy cities. Like in 2012 in Venice, when a waterspout forms over the sea and heads directly towards the city. Waterspouts are usually weaker than tornadoes, but they can also reach speeds of up to 300 kilometers per hour. Over water, they are especially dangerous to ships, but they can also move onto land. Such was the case with Venice. The aftermath? A trail of destruction more than 10 kilometers long.
Waterspouts are shorter lived than tornadoes, from a few seconds to a few minutes.
In May 1999, the fastest tornado to date strikes the United States. With a maximum speed of over 500 kilometers per hour, it whips through the state of Oklahoma for 85 minutes at the highest wind speed ever recorded on Earth. It caused $1.2 billion in damage. It is one of the world's costliest natural disasters, in which 48 people perished.
Whether a tornado will form depends on the specifics of the movement of air in the location. So how these two masses of air rotate around one another and interact with one another. And it's not always possible to predict very accurately whether a tornado will form. And of course, if you can't predict whether a tornado will form, then it's quite hard to assess what the consequences and damages will be.
Even with our modern surveillance systems, surprises still happen to this day. Like in Texas in May 2022. There is no early warning issued for the city of Round Rock. A tornado appears virtually out of nowhere. Residents desperately try to run to safety. The tornado leaves behind $32 million in damage and destroys more than 680 homes. To avoid such surprises as much as possible, there is another important weapon in the fight against these forces of nature.
Spotters are people who contribute with data from the ground. So via their phones, they're reporting in actual ground observations and measurements. And those observations are then fed back into the models, making them much more precise.
The U.S. has the world's largest network of volunteer spotters. They are organized on a volunteer basis and report their observations to the local weather service. Spotters help to compensate for the weaknesses of radar technology. This is because it has gaps in the event of weather changes in the immediate vicinity of the ground. In addition, there is also a decisive time lag. Spotters verify tornadoes from the ground and make an important contribution to countering this force of nature.
Many amateur storm spotters are passionate scientists who see the thrill in it, but also they have a passion for the subject. So they will look into the skies. Many of them have quite sophisticated equipment to spot storms from the distance, and they play a crucial role in the early warning infrastructure that we have. The more eyes look at the sky, the better.
Now there is even a global network consisting of several 100,000 severe weather warning devices.
This is essentially a community thing. Storm spotters exist to warn communities that storms are approaching, and they're able to buy people in the communities time to put plans in place.
Spotters often double as storm chasers. There are a large number of hobby storm chasers. They are largely disaster tourists who chase a storm to capture spectacular film and video footage.
Storm chasers are following the storm on the ground and try to go as close as possible. So they're doing it partly for the adrenaline kick as a hobby. But because they are feeding valuable data back to the scientists and the models, they're also serving their community, which is something that they find very fulfilling. The positive effect is that people on the ground can, in some cases, be warned in case the weather predictions haven't really told that there will be a tornado, but the storm chasers have actually seen that there is forming one, so they can actually warn people on the ground.
But there are also professional, scientific storm chasers, whose aim is predicting the dangers of tornadoes with maximum efficiency. They don't chase tornadoes to pass time, but rather to generate as much data as possible. This will help make even more accurate weather forecasts in the future. But there's also an element of danger involved. They need to get as close to the storm as possible to observe what is happening in the sky. Their equipment consists of meteorological measuring instruments, as well as mobile weather stations and radar equipment. These have been around since the 1990s. They are special vehicles equipped with weather radar and a control center. Scientists travel many thousands of miles on week-long research trips to spot tornadoes and study them more closely. They attempt to reach the cells of a thunderstorm before a tornado develops. This is important so they can set up their equipment without running the risk of being caught by the tornado.
Scientists are only able to track about 2% of all the tornadoes that occur every year and do research on them. And this is mostly because there are so few scientists compared to storm chasers and spotters.
Using the mobile radar vehicles, scientists can drive very close to the storm to document its characteristics.
The advantage of mobile instruments is that you can actually take them where the tornado is. Scientists have fixed instruments that look regularly, but the problem is that the tornado is probably somewhere else where your instrument is. So this is where the mobile instrument units come in. These are used by professional tornado hunters. They take their truck to where the tornado is, and thereby you get much more accurate local information. And this is what you need in order to understand where the tornado is coming and also how severe a tornado it is.
When a visible or condensed funnel cloud moves downward, both scientists and hobby storm hunters know that it won't be long before the vortex touches ground. It's enormously important for storm hunters to maintain a safe distance to avoid entering the tornado's wind field and being swallowed up. Touchdown. Contact with the ground signifies the birth of the tornado. The crucial question now is, will it start moving? Phase 2, the battle against the forces of nature begins. Pursuit. When a tornado touches down, storm hunters immediately contact the Weather Service to report their sighting. At this very moment, a tornado watch becomes a tornado warning. As a result, authorities in the affected region ensure that warnings are issued through all available channels. Tornadoes pose a danger to property and life. As soon as it starts moving, all storm chasers, mostly in squads, set off in pursuit. Hobby chaser vehicles are often modified for heavy storms, with enhanced engine power and sometimes even armor. While the hobby chasers follow the path of the tornado, scientists try to get in front of it. Their plan is to anchor measuring instruments in the ground in the anticipated path of the tornado, so that it can pass over without destroying them.
Scientists want to get as much information as they can about the atmosphere, the wind speeds. Only if you have lots of data can you give an accurate prediction of where the tornado will go and how important or how dangerous the tornado is. The problem is that the instruments are usually not where the tornado is. And you can place the instruments close to the tornado on mobile units, but usually the tornado is a little cheeky thing or a big cheeky thing, and it goes where it wants. And so it's a game of luck whether or not your instruments are actually spot on where the tornado is. So it is never something you can predict.
Most tornadoes maintain a relatively constant speed, but there are exceptions. In rare cases, this changes abruptly. things can quickly become dangerous for anyone caught in a tornado's path.
So a tornado has a so-called death zone in it. And in there, it's freezing cold and the oxygen levels are very low.
Air turbulence creates different temperature conditions in a tornado. In its center, it is bitterly cold, but it gets warmer and warmer toward the outside. This temperature difference combined with a sudden drop in pressure is a potentially lethal combination. Conditions in the center of a tornado may well be like those at 8,000 feet above sea level. But it is not only dangerous in the eye of a tornado, it's vital that storm hunters avoid the entire wind field. Several storm hunters have lost their lives pursuing tornadoes in the past. Like on the 31st of May 2013 in the U.S. state of Oklahoma. Oklahoma is located in what is known as Tornado Alley. Here, moist air from the Gulf of Mexico meets dry air from Canada. The strongest tornadoes in the world are consistently produced here. The catastrophe begins at 6:03 p.m. The vortex of the El Reno tornado touches ground, and the natural disaster takes its course. Its special feature is a rain-enveloped multi-vortex tornado, with several vortices all orbiting around a common center.
In addition to the main vortex, they have several sub-vortices circling around the main vortex. So they're incredibly destructive. So multi-vortex tornadoes are very destructive because you have a main tornado which has a relatively low wind speed. It has a low wind speed because it has transferred much of its angular momentum to the smaller vortices around it, which form the multi-vortex tornado.
Secondary vortices are extremely dangerous. In some areas, they cause very little destruction, but in other areas, complete chaos.
Doppler radar measurements of wind speeds in the outer vortices showed that wind speeds are as high as 475 kilometers per hour, which makes them the second highest wind speeds ever measured on Earth.
Plus, its enormous size. Its diameter is 4.2 kilometers. That corresponds to a traffic jam of 900 cars lined up in a row. It's the largest tornado ever recorded, possessing tremendous destructive power. After just 40 minutes, El Reno dissipates. 40 minutes in which more than 150 people are injured and 9 people lose their lives. Among the victims are 4 storm chasers. To this day, one of the biggest problems for amateur chasers tracking tornadoes is that their radar data comes with a time delay.
Hobby chasers are often just using smartphones for their information. Now, this information has to be relayed from the weather stations through the apps and so on, and can be something like 15 minutes out of date. When you have a situation like around a tornado where the weather is changing so rapidly, having that out-of-date information can be really dangerous. If you happen to be in the wrong place because you get incorrect information, you could find yourself very close to a tornado where there are wind speeds of up to 300 kilometers an hour.
I mean, you'll have 15 seconds to get everybody in the car. No, back in the car. Back in the car. We're gonna get hit with 100 mile an hour winds. My God, what a tornado! Holy crap! Violent tornado! Violent tornado!
The time delay can be a decisive factor in whether a hobby storm chaser can still manage to escape. A chaser's best tactic is to avoid crossing the tornado's path. In most cases, a distance of 1 kilometer is usually sufficient. Unlike hobby storm hunters, scientists get their data in real time thanks to their mobile weather radar. They try to minimize the risk as much as possible by following the tornado closely while always keeping an eye on how it changes. Scientists position their radar to create a kind of net in front of the tornado. This gives them more precise information about the tornado's characteristics.
Professional storm tracers or tornado chasers, they try to understand how strong the tornado is and where it goes. So they need to measure the wind speeds. The circular motion, the circular wind speeds, they tell you how dangerous the tornado is. And then the translational speed, that's the speed along its path, and the direction, that tells you how quickly it moves and in what direction it moves.
It is particularly important to record the velocities that prevail near the ground. This is where the tornado causes the most damage.
This is where storm chasers come in, and any observers really. Storm chasers make very accurate local measurements of tornadoes. They are very courageous people. They go very close to the tornadoes and give information that nobody else can really provide. And by doing so, they even risk their own lives. But this information will help scientists better understand what processes are dominant and therefore understand with time how a supercell tornado will form and, crucially, when it will form.
The scientists collect as much data as possible. This allows them to create more accurate models that lead to better weather forecasts and warnings in the future. One problem remains. Not every tornado is visible.
To the naked eye, the tornado looks like a wonderful column. They're actually very beautiful. They are columns of condensated water connecting the ground with the cloud above. And so the vertical column is the trademark, the visible trademark of a tornado. However, it can happen that sometimes this vertical column stops before the ground. So it doesn't visibly connect to the ground. Unless you are an experienced storm chaser, you might be misled into a sense of false security, believing that the tornado hasn't hit the ground, so there's no danger. But in fact, the winds will already, in many cases, reach the ground, be just as high and just as destructive.
Even if the tornado appears only in the air, it can still be very active on the ground below.
That sounds, kind of like a joke, but actually that's quite dangerous. If you can't see the air moving, and it's already hit the ground, then you could be in danger on the ground but not know it.
Another uncertain factor for hobby chasers is the actual size of the tornado. If the vortex grows too quickly, escape is the only option. Tornadoes can move in any direction, but most whirl from southwest to northeast. In populated areas, the authorities can issue warnings of its likely path. But tornadoes can also deviate from its predicted path. It doesn't happen often, but when it does, it can be extremely dangerous. So, it's vitally important to monitor whether a tornado holds to its anticipated direction or deviates from it by a few degrees. What options do we have to stop a tornado? How can we protect ourselves? Do we stand any chance at all against this unpredictable force of nature? It's important to take severe weather warnings seriously and react quickly. Today, we have smartphones and the internet. This makes an enormous difference compared to a few decades ago. Back then, people could only be reached via the usual communication channels. Television, radio, and newspapers. Today, large sections of humanity can be reached in an emergency within a very short time.
So 20 years ago, people didn't have the range of technical devices that would allow them to get real-time warning. They didn't have, for example, mobile phones that could warn them right on time. So it happened much more often that people were taken by surprise by tornadoes.
Today, people can make preparations in time.
The people on the ground, they basically have to go to their shelters. But then there are also other institutions that have to know about tornadoes. For example, hospitals. You don't want to have a tornado passing over you while carrying out a heart operation. So you basically need to warn hospitals and any other critical infrastructures of tornadoes coming by.
In the event of a warning, at least a few minutes remain.
Because of the more up-to-date information, we now get something like 10 to 15 minutes warning that a tornado is coming. And while that's much better than before, when there basically was no warning, it's still a really short amount of time, particularly, if you need to pack up things and evacuate an area.
More and more cities have community bunkers that provide shelter for people in the event of a disaster. In areas particularly susceptible to violent storms, people learn at an early age what to do in the event of a tornado.
Areas affected by tornadoes are the areas where you would build community shelters. Because tornadoes can happen, will happen regularly, and so people need a safe place to go to. Any structure reaching up from the ground is not safe. So what you want to do is you want to put the people under the ground in one of these very robust shelters. And of course, people construct these shelters in the areas which are regularly affected by tornadoes.
People follow local evacuation plans and swiftly move themselves and their families to safety. Police, firefighters, and other disaster relief workers ensure that people who are still outside find shelter indoors.
So the right behavior is key for survival. People in tornado-prone areas usually know what to do, and they are quite well prepared. They listen to the authorities, and they have their supplies ready, and they have shelter.
People are safest in a shelter, or better yet, in a private bunker. In most cases, people rely on their basements and other underground storm cellars for cover. They're in the least amount of danger there. However, during heavy rainfall, this option can also become dangerous through the risk of drowning. The moment a tornado begins striking houses, chaos breaks out. The violent whirling winds smash windows and rip doors off their hinges. Dirt, dust, and debris fly through the air at extremely high speeds.
The roof of the building just blew off.
The fastest tornado to date, the Bridge Creek Moore tornado in 1999, displays the power that lies within these mighty winds. A mass of 320,000 tons, the equivalent of more than 5 million washing machines, moves across Oklahoma in 85 minutes, demolishing everything in its path. The 200 homes destroyed in the town of Bridge Creek alone represent 115,000 washing machines swirling 10,000 meters in the air. Passenger planes usually fly at this altitude. An immense force. Bridges, subways, and cars. Everything that can be lifted off its hinges offers no protection in a tornado. The scientists' efforts, however, don't end when the tornado dissipates. Experts can determine wind speeds by examining the damage.
Tetsuya Fujita, a scientist from the University of Chicago, in 1971 introduced a scale that essentially puts each tornado into a category of how destructive it is.
Scientists in America make use of an enhanced version of the Fujita scale. It covers the stages from EF0 to EF5. The weakest level reflects only light damage to roofs and trees. At level EF3, trains derail. At stage EF5, the highest level, everything is flattened to the ground. Tall buildings, steel structures, and trucks are unable to withstand these massive wind speeds. But with the aid of technology, we can react and warn people.
In order for us to be able to better predict tornado occurrences and to better understand how destructive they are, we need better computers to analyze what we see on the ground. And this is where quantum computers will play an important role, because they will multiply by many dimensions our ability to calculate something which ultimately is a chaotic phenomenon.
Simply put, quantum computers are able to make computing operations more efficient. That saves an enormous amount of time, and time savings are extremely important in weather forecasting. The study of tornadoes is a field where there is still much research potential. Our technological development is constantly providing new insights that advance our research. But we still need to better understand the complex processes involved. Scientists and courageous storm chasers put their lives on the line to find out more about the nature of tornadoes. That's the only way we have a chance of defying these forces of nature.